We are using the OpenStax textbook Calculus Volume 2, and this section 3.4 partial fractions is probably going to be a pretty long series of videos simply because I feel like partial fraction decomposition is something that doesn't necessarily get taught as much anymore prior to calculus. It used to be that you learned it in pre-calculus or math analysis, somewhere around there, and then we used it in calculus. But now I think we're at a point where most of you probably haven't done partial fraction decomposition before. So I'm going to take a little bit of time as we go along and teach you the method of breaking down your fraction in that way. Before we do that, I want to remind you real quick of these rules because they are going to be very useful. We're going to use those a lot. Now, you should have a list of your integrals anyway, but those are going to be very helpful. Now, when we look at this problem, the integral of 3x over x squared minus x minus 2 dx, we do not have a rule that will just jump in there and solve that thing. Because if we use u as x squared minus x minus 2 and du is 2x minus 1, we don't have a du. We don't have the information that we need. So what we need to do is try to break this up. I'm going to explain how that works. So we're going to ignore the integral for a little bit, not even worried about that part. We have 3x over x squared minus x minus 2. Before we go any farther, I want to say that this, what we're getting ready to do, works because my top power is lower than my bottom power. In a little bit, we're going to do another example where the top power is higher, and we're going to do long division first. But here, long division won't work. So you have to factor your denominator. And in this case, I get x minus 2, x plus 1. And basically, we are going to uncommon denominator our problem. Okay? But we don't know what our numerators should be. I've put a capital A and a capital B there. I think the book uses like a sub 1 and a sub 2. I just use A and B. I think it's easier. It's the way I learned it. And what happens is, because our denominators were linear, x to the 1, then our numerators are going to be constant, which means no x, just a number. We are going to pretend like we're putting the blue problem I've got here back together. So we're going to multiply by x plus 1 here, and by x minus 2 here to get a common denominator. It'll all make sense eventually, I promise. So I have x minus 2, x plus 1, and on top I have ax plus a plus bx minus 2b. Now, my denominator here matches my denominator here. We can say that my numerator here has to match this numerator. So we're going to set this up as 3x equals ax plus a plus bx minus 2b. Well, we still don't know what a and b are, but we're going to, because you break this down into like terms. So x's, I have 3x equals ax plus bx. And constants, I have 0, because 3x didn't have a constant, equals a minus 2b. In other words, I grouped my equation into like parts. And since the a and the b over here didn't have a corresponding part on this side, we gave it a 0. Now, we actually aren't going to keep our x. We have 3 equals a plus b. And here, if I add the 2b here, I have a equals 2b. We're working like this is a system of equations. So I'm going to put 2b right there. 3 equals 2b plus 1b. 3 equals 3b. So 1 is b. 2 times 1 is a. So 2 is a. Okay, so what does that do for us? If a is 2 and b is 1, then I can rewrite my problem now as the integral of a over x minus 2 plus b over x plus 1 dx. And now we can use U substitution for this rule. So we have the integral of 2 over x minus 2 dx plus the integral of 1 over x plus 1 dx. Each of those gets their own u. U is x minus 2. Du is 1 dx. So the 2 technically goes out here. There we go. Here, u equals x plus 1. Du equals 1 dx. We got that. These rules give you natural logs. So 2 ln absolute value x minus 2 plus ln absolute value x plus 1 plus c. And that's how partial fraction decomposition works. And I think we actually worked ahead of where we needed to be for this, but it gives you a pretty decent idea of what's going on.